The Earth is red, and we need a solution. A green solution and a blue ocean strategy. According to a NASA postdoctoral fellow Zoe Piot on her TED Talk, in 2009, a satellite scanned CO2 wavelengths of Earth globally, but the results showed a glowing red hue of Earth caused by plants photosynthesizing. This information is now used to contrast past findings of the Earth's natural biomes. We live in a colorful planet that our eye photosensors register in red, green, and blue. In the modern world of fast-track technology that heavily relies on science to answer our questions that are simply unfathomable to the bare eyes, but by the help of nature, mankind has discovered the wonders of sea creatures that view our ocean very differently, and it was just the findings we needed to unlock the world's colorful mystery. Professor Justin Marshall studied mantis shrimps that can see in multichromatic lens that help them navigate the ocean floors, almost like little googly-eyed marine cartographers, or better yet, satellites. Imagine if we had eyes, or rovers, satellites to be specific, a device strategically placed inside heavily wooded areas of our planet that are prone to wildfires in promotion of national risk reduction and the UN Sustainability Act, to be able to monitor our planet's ecosystem and combustible areas based on the chlorophyll fluorescence in the mission to protect our lands. Think smoke detectors, but more connected, high-tech, and low-cost. This can be possible through this business speech for microorganic photodetectors embedded into plants, an aid to natural disaster risk reduction of wildfires in combustible areas of vegetation. The detector is wired to an observation satellite that scans the spectral signature of carbon dioxide in a plant's chloroplast during its photosynthetic process, while checking for moderately high temperatures indicating the conceivable presence of fire. This information will be accessible real-time to everyone on the internet to promote unity and volunteers on the watch for these hotspots. With this sensor connected to our satellites, can we communicate and alert nearby stations and voluntary communities to gather around and implement wildfire rescues to stop its spread that has been a recurring problem since the year 2020, when we've unfortunately lost parts of the Amazon forest to a wildfire. Circa July 2020, when an Australian region burned with most of its wildlife, with 100,000 acres of Californian forest set ablaze in the year 2021, and recently, the devastating Maui, Hawaii wildfire that had cost its residents their homes, children, and cultural heritage. Now, how does it work? We use the same mechanics of a regular smoke detector, but eliminate the expensive lithium-ion batteries and instead make the device solar-powered, like the same compact ones used for cheap yet durable calculators. With this, we will also deduct the ionization chamber and relay contact in the design but retain the RF module and invest in programming the remaining photoelectric device to a real-time national satellite IoT using the wireless RF signal. The new reinvention of the smoke detector becomes a cost-effective, accessible, and diplomatic version of itself that brings responders, communities, and researchers together. We not only eliminated and made great revisions to the product that makes competitors irrelevant, we've also ventured out to building a community of evacuation and rescue planning, uniting local governmental units for financial aid and security implementation, and sealed in agricultural real estate inclusivity. Our current market are the government-managed and preserved agricultural lands and environmental enthusiasts, but we ought to persuade private real estate owners to invest in the device for their farmlands and even so market it with curious researchers and scientists. This device might even be considered for an unexplored substitute for better and improved smoke detectors in regular households. The Earth is red, but in a good way. It means plants are living and the planet is breathing.